All right, welcome to the June 2023 OpenZFS leadership meeting. Have a couple of exciting topics on the agenda today. So Don, why don't you kick it off?
Okay. Yeah, I'm going to do some contract work to see the RaidZ expansion to completion. I know there's been somewhat of a stall in recent in the recent past, and so I just want to give that update. I started on it last week and successfully rebased the current master and have been running tests. I've observed a few issues that I'm working through right now. So hopefully I'll have a pull request open. I would guess this week if I can hopefully resolve the issues, and then we can move forward to iterate it to completion.
Awesome. Look forward to working with you. If there's anything I can do to help out, walk through the code or anything, happy to help out.
That's great. Yeah, I'll walk through. I'm entangled with it by debugging these things until now. I'm sure I'll have a big list of questions of how things work or why things were made the way they were. I've been going through the test suite test and annotating those, and also I'll probably have some question as to why we're testing it that way. Those might be for I can't remember his name, but it was VStack, I think, that had done those tests.
Fedor, yeah.
So, but pretty good set of tests to start with. So that I'm grateful that those tests are there, because it's exercising the code. So
Awesome.
And I think the last bit of work, those pull requests that you had mentioned to me, Matt, were all about Z tests. So my plan is to take that on sort of second after I get all the test suite stuff working.
Makes sense. Did you want to mention who is contracting you to do this work?
I think it's okay. I don't think I'm under an NDA. It's IX Systems. So Alexander's company.
Cool. Well,
and it makes sense because it's more of a hobbyist, I guess, so TrueNAS scale would probably pick it up.
Cool. Well, thanks a lot for being that worked on, and thanks a lot to IX Systems for sponsoring that.
Because they sponsored the original work as well, right? That you started, Matt?
The FreeBSD Foundation sponsored the bulk of the work or they sponsored all the work that I did. Yeah.
Oh, the first one back in like 2016 or whatever? I think IX was part of that then.
Okay.
Anyway.
And I don't know if VStack is still, had they put any money in, or just maybe time for the testing?
They were doing work like doing some development and debugging and stuff. So, just contributing in the open source collaboration aspect, which is great. Cool. Well, I know that work is long overdue, and I look forward to seeing it completed and put into production. I regret that I wasn't able to get it all the way done. But if I can do anything to help out, happy to do so.
Cool.
Cool.
Hey, Alan, this is Ed. Just a quick comment on that too. IX has definitely had an interest in this for a long time. Yeah, as Matt said, the foundation was the primary sponsor of the bulk of the work from the beginning. I think IX did contribute a small amount early on as well.
Right, the 2016 or 17 when it first started.
Yeah,
I think maybe possibly just via the foundation even.
Yeah. But in any case, IX has certainly had an interest in it for a long time, and the foundation also has an interest in it. So I'm very happy to see that it's going to finally come to a closure. Also, I think it sounds like things are in good hands. But if there's anything from the foundation's side as well that we need, I'm happy to have that discussion as well.
Yeah, I don't know if folks would be willing to do a test run on FreeBSD side. I don't currently have a setup to do that, but I can probably set that up.
Yeah, I'll send you a note offline, and we can see about. I mean, I've got some interns and things as well that might be able to try out some testing at the same time and things like that. So we'll see if there's a good way to collaborate on that.
Cool. That's great. Well, I look forward to seeing your new PR and closing my very outdated one. All right. Next item on the agenda we have from Tino around testing.
Hello. Sorry for my bad English, of course. I'm German native speaker, and my English is not the best, but I will try my best.
No worries.
Reading English is really easy for me, but telling something in English is a bit difficult. So can I put my screen on into the Zoom meeting?
Yeah, sure thing.
Okay. Is it seen?
Yeah.
Yes. So we got access to a lot of machine. This is an overview. I'm sorry, this is in German currently, but you see we got access to PowerPC 64, little endian or big endian. That's up to us. What we want to use. A lot of RAM, CPUs, and instances at a maximum of 10. And there are already inside some different distributions. Currently, no BSD on this CPU type because the GitHub Action Runner will not run currently on PowerPC, but on ARM. That's another account. I will just log into it. So there we have FreeBSD, Fedora, Alma Linux, Debian, and so on. And all these instances have 2 CPUs and 30 gigabyte of disk space and 4 gigabyte of RAM. And these will distribute action runners for us in GitHub. So we can just define our YAML stuff and it will run on every machine. And after it is run, it will completely reset and then be free for the next run, of course. This is the list, which is currently active on my personal GitHub ZFS settings. We can just pull this over to OpenZFS when it's really done, when it's ready for distribution. And I can, of course, show some action which is done just before some minutes. So this is an ARM system with some beginning of setup, not currently finished. Here we have the runner. It's a special runner. It's another different project from here, Christopher Hikes, and he has made with the language Go some nice scripting for working around the limit of GitHub action runners to run only on AMD. So this runner it emulates a full GitHub action runner, and it's done on a lot of different CPUs. Maybe we have a list. Yes, in releases. There we have all the different systems which are supported. This is the full list. And you see we can run it maybe everywhere, GitHub Action Runner with this thing. But currently no PowerPC on FreeBSD. PowerPC is only supported on Linux currently because Go is the limit. The Go language isn't ported currently on FreeBSD PowerPC. When this is done, OpenZFS can also be test compiled and all the testings can be done also with GitHub. So I will switch back to this overview. Currently, all these runners are idle, and I will create just a small YAML change to maybe run something on ARM FreeBSD 13. And Linux, of course, and CentOS maybe. So this list can be changed easygoing every time. Project test X. And then we will see that some of the action, of the available runners will run. They are changing from idle to active. They are executing, of course, some stuff. We can see the output here. So this runner is running on ARM, FreeBSD 13. This runner is running on PowerPC, Alma Linux 9. This one is running also on PowerPC, Little Indian, CentOS 8, and so on and so on. So we can, all these 25, 27 boxes I have currently could be in this list, and they would be run some building of ZFS and testing. So I think this would be really cool when this is finished and we have it upstream. Yes.
That's great. The testing that you're doing on these machines, is it just building the building ZFS, or is it running like the ZFS test suite or Z-test?
The full test suite, of course.
Okay.
The full thing, and we have we can do this. We have the okay from the director of the open source lab there.
Cool. That's great.
Yes.
And so the other question was about kind of resource utilization. You have that list of runners. It looked like there was like one of each type.
Yes.
Like each OS and CPU architecture. Is the idea that like when you run a build, when you open a new PR, it would kick off a build on all of those different ones, and then like if there are two PRs open at the same time, kind of one of them would be running the tests, and then when the machine frees up, there's only one, like there's one ARM64 Alma Linux 8 machine, and that's going to run the tests for one PR, and then when that's done, it can run the tests for a different PR.
Currently, it's limited by this number 10. We have only 10 instances, and we have 10 different system types. Or we take away some distributions here, and then we may also have 2 Debian 11, or then we can maybe have more power for the real test. I don't know how long the full testing suite on all these machines will run. I did it some day with PowerPC, and the PowerPC machines are on NVMe. They are really fast. So this, I think, maybe 2 or 3 hours for the full testing, but not more. the ARM and the AMD systems are a bit slow, but AMD, of course, you may also take over the thing, how it's done, the open and set up also some OpenStack with own AMD machines, and then we can also start another cluster of new runners. Maybe the build board can be replaced with this, because then we have all the same in simple YAML files, of course.
Cool. And do you know what hardware is backing these? Like for the, I'm especially interested in the ARM64. Do you
Yes,
know what hardware they're using?
There's a site, moment. Yeah. Hardware stick. Can you see it?
Yeah. Okay, so it's an Ampere system. Cool. I think this is great. I think testing on these additional architectures that like ZFS works on, but it's not really tested, at least not for every PR. Getting that testing consistently would be wonderful.
I need some time, and then I will start a pull request for it, and then we have it, I think.
Great.
Are there any questions or some other hints? What should be used? Another distribution, for example?
I know Amazon had offered to donate resources to run more of the ARM64 testing on their Graviton instances as well. It's just mostly, I think, a matter of coordinating that with them and actually hooking up the stuff to run those builds.
Yeah. Tino, do you mind stopping your screen sharing so that it's not like going through a couple of different hops? Yeah, so we have Amazon has given us some resources to the OpenZFS project. Tony, do you want to talk about what you're working on, moving some stuff over to there? So far, I think we're just doing the x86 stuff, but it definitely could be possible to use that for ARM64 testing on them as well.
Yeah, I can go into it a little bit. So I've been working on a couple different things with our OpenZFS AWS account. The first thing is moving over our S3 bucket that hosts all of our repositories, all of our RPM repositories, from the Livermore National Lab S3 bucket to the OpenZFS one. Second thing would be moving BuildBot to run on the OpenZFS side, or on our OpenZFS AWS account. And then the third thing I'm working on is looking into the future. It would be nice to convert all of our BuildBot stuff into GitHub runners. And more specifically, I'm working with this project called EC2 GitHub Runner, which basically spawns off a GitHub runner, and then that spawns off an EC2 instance. And that allows us to run OSs that aren't supported natively by GitHub runners. So right now, I think they just support, as far as Linux goes, like Ubuntu, but we need to test on Fedora and CentOS. So I've been kind of in the shadows testing that. I've got it to basically run Hello World in an instance, but that's kind of like 80% of the work because there's just a lot of setup you have to do. So hopefully one day we'll be able to stop using BuildBot and just go purely with runners.
It sounds like the solution of having a GitHub runner that then executes, like then controls another machine, is maybe similar to the thing that Tino was showing us to like create a GitHub runner on this other architecture. Did I understand that correctly?
Yeah, it sounds very similar. The only difference is that the instances that my stuff would be spawning off would be in EC2 versus real hardware.
Yeah, so maybe yours, it's like it has a little bit more tight integration with EC2 to like actually create those instances on demand versus like the theme team is using. It's just like there's already a machine sitting there and it's going to run some job on it.
Yeah, exactly.
Cool. Well, I mean, that all sounds great. I think expanding our test coverage is wonderful. And so I look forward to seeing both of these projects move along. Questions for Tony? I guess we got there by talking about ARM64 testing. Tony, have you thought at all about using the Amazon Graviton stuff for testing?
I haven't thought specifically about that, but there's nothing stopping us. I mean, we can launch any instance we want, in theory.
Cool. Yeah, I mean, those are the ones that personally I'm interested in, those instances, making sure that those work. I think probably there's a lot of folks, at least people who are doing ZFS in the cloud, that's probably the at least second most popular architecture that they may be running on.
Yeah, for sure. And in general, those Amazon instances are less expensive than the x86 ones for the same performance. So if we can work there, then it's a big win.
Yeah. I mean, it's something where like maybe if we don't have the money or resources to test everything fully on every OS and platform combo, we can do the full tests on the cheapest ones, which might be AWS Graviton, and then do a more limited number of tests for every PR on the other platforms. But we can get to cost optimization once we have something working. Cool. Other topics for today's meeting?
I guess Brian's not here. I was wondering if we had a status update on the 2.2 release or the next version release of OpenZFS.
Last week, he mentioned to me that he'll be on vacation this week and should return next and start the branching process.
Okay.
He could start it before, but was already traveling somewhere.
Makes sense.
So I can't wait for it to happen. We are stretching it quite a lot. In which context, partially related, if somebody has time to review a few patches, I have half dozen different optimizations, bigger and smaller, right now open. It would be cool if they could be landed before. Brian saw most of them and was okay with it, but a few more eyes would be good because things happen.
Yep.
Yeah, sounds good.
Does anyone happen to know, like, kind of similar to Alexander's point of what the cutoff will be for, I'm guessing in order to get into the next long-term release of Ubuntu, we'd have to have it out in time for the next not long-term release of Ubuntu, so they have a release of testing before or whatever. It's like, how soon does 2.2 have to be ready to make sure it makes it into the next Ubuntu? Because I have no idea.
I also have no idea. Maybe this is a question for the mailing list. Somebody there might have a
Yes.
The next Ubuntu LTS is April 2024.
Right. That's when it'll be released. So they'll obviously need ZFS to be stable before then.
I mean, I don't know. I'm not involved in their development process, but I would think this fall, probably.
Well, in particular, I wondered if it had to be ready for their 2310 not LTS release, so that you know, they've basically shipped it
I would
and know it's
certainly
stable.
like to, yeah, I'd like, as a user, I'd like to see it having gone in one of the interims, yeah.
Yeah, and so, but it sounds like the Brian's plan will meet that requirement, so we're okay.
I would think.
But yeah, if we start getting releases in 2 weeks, then, or release candidates in 2 weeks, then we should be okay.
Sounds good. What else do folks have to talk about today?
There's one more thing, if somebody want to comment. There's a PR open to increase dedup blocks from current 4K to something bigger, and there are going discussion to how high could it be, and current consensus to try to go to 16K. Because I was wishing to go higher, I'm trying to push it lower. But if somebody has other ideas, small PR is open, practically changing default and making them tunable. So Alan Science, so your team is also working in that area. I would appreciate your comments if you already have any numbers. I mentioned you there already from the point that maybe it doesn't worth to touch on it right now while development is already going in parallel, but seems like guys interested to push it. So if you could go and
yeah, and I can also see the point of, you know, the work we're doing won't be in 2.2 if it starts shipping in 2 weeks. And so do we want to at least have tunables by then? But I don't know, but I agree with you. I don't know, changing the defaults is a good idea at this point. We've mostly been focused on the work to make the amplification not as bad. And then once that's done, we expect that increasing those indirect and the leaf block sizes will have much less of a penalty. But until we're there, we don't have as many measurements as we'd like, but we can do some in the interim to validate what it looks like. Because we saw for a different customer, completely unrelated, it turned out they were using Dedup, and while doing some benchmarking, we saw transactions stalling for multiple seconds, just iterating over the Dedup freeze. And so just the fact that a lot of blocks were overwritten in this transaction meant that the transaction just sat there spinning at the end. And that was quite suboptimal for, you know, they're doing FIO and then there's just a pause for seconds while no new writes happen because the transaction is flushing and the next transaction group is already full, or it hit the dirty max. So yeah, there's a lot to be done there, but I'm with Alexander that at the moment, I think increasing the leaf size there would just make it worse. While you do get the advantage of compression, and maybe it'll make the on disk size of the Dedup table better, and maybe even allow more of it to be cached in RAM, I don't know that the amplification will be worth it, but maybe it's up to the user to make that trade-off.
Yeah, speaking of dedupe, there was some talk about doing an offline dedupe based on the, you know, various new kinds of block pointers. Is that something?
You mean on BRT?
Yeah. Is that something that's actually likely to be worked on?
If there's interest, I suppose. But right now, what Clara's working on is just a different way of doing dedupe that will not suffer as many of the problems, kind of taking some inspiration from Matt's original log dedupe idea, but applying some, trying to deal with some of the limitations it had of the whole DDT having to be in memory all the time. And just the way the Matt's version had to rewrite when it condensed the DDT, had to rewrite the entire thing as one transaction group, which again could lead to that thing of the whole system sits there and waits until that transaction is done writing out. And if your dedupe table is 100 gigs, that could take significant time.
Yeah, I mean, in terms of interest, yes, we ran for a while with dedupe on, and the saving was really quite dramatic. It was like 2 to 1.
Yeah, I think at a high level, like the stuff Alan's talking about is like an implementation detail of the current dedupe. property and how that all works. Versus the block reference table BRT thing is like a totally different
Yeah,
mechanism.
right, I
Uh,
understand.
That could be used for like after the fact dedupe. But I don't know that anybody is working on that right now.
You know, it was a science experiment I wanted to play with in the back of my head, especially for something like, oh, I have these two VMDK files that are similar. Go find the blocks that are the same and use BRT to fix them. But with our current work on dedupe, maybe we can get dedupe to not suck enough that you don't have to worry about trying to do offline dedupe.
Yeah, that'd be great.
I don't know, Matt, how much more do you want me to say about that? Like, do we want to look at the design stuff or not yet? Or
I mean,
Up to you.
you muted again, sorry. I didn't catch what you said.
I say me. I guess it would be interesting to show people if you have something to show.
I do. So let me fire that up quick.
Yeah, that would be interesting.
All right, so just a quick slideshow here, talking about some of the problems with dedupe and then how we attempt to address them with a laundry list of design changes to dedupe. So the biggest thing is that with dedupe, you have to do the read before the write. So every time we get a write, if the DDT is not cached in memory, we have to do a random read to disk, or usually multiple through the indirect blocks and then the leaf block, to find out if this particular hash is in the DDT. And kind of to what Alexander was talking about before in that pull request, part of the issue is that we store those leaf blocks in very small records, 4K each, and even the indirect blocks are also limited to 4K instead of the default 128K for each. But that's because of the write amplification problem, which we'll get to in a second. The other problem is the DDT is sorted by the hash. So if you know, during this transaction, we wrote 100 new blocks. The hash means that those are going to be kind of evenly distributed across the entire DDT. So we're going to be writing separate blocks of the DDT for each one, depending on the size of your DDT. But in general, the writes are going to be randomly distributed across the whole DDT, not all concatenated or grouped together like you would have when you're actually writing the transaction to disk. Then we have the size of the DDT. It's a relatively big data structure. Part of that is each entry, so for each hash that we have, the key is 384 bytes, but the body is even bigger because we have the 3 DVA slots multiplied by 4 sets. So we actually stored 12 DVAs for every dedupe entry. One for all the DVAs for a copies equals 1 block, one for the copies equals 2, and another for copies equals 3. And then there's also still the deprecated support for ditto blocks, where if we dedupe a block a lot, we'd write an extra set of copies of it. And so that means we're having a lot of these very large DVA slots in every entry, when most of the time, almost all blocks that dedupe are going to have copies equals 1. And even if they don't, there are ways around that. And then the IOPS amplification, especially if you're doing a ZVol with, say, 8K record size or vol block size, if every time you write 8K for that or a database or whatever, you're also writing a 4K block of the DDT and its indirect blocks, then you can end up with, you know, more of your IOPS going to updating the dedupe table than to actually writing data to the disk. And that can really hurt. And the same thing can happen with just running out of write bandwidth. So part of that, the first thing would be implementing a dedupe quota. So if the amount of data we're deduping or the size of the dedupe table is going to be too big for memory or for a dedicated device, if you have a dedupe special device, then we'd be able to say, you know, once you use up this much of the DDT, we'll stop deduping stuff in order to have enough room. But for that to make sense, you know, Claro tried to implement that in the past, but the problem was without the zap shrinking work, the dedupe table never got smaller. And so as soon as you ever hit the limit, no matter how many blocks you erased, you'd never get any dedupe in the future. So with the zap shrinking work, we're now able to actually shrink the DDT and get room back. So when you delete files, you'll be able to continue and move forward and get dedupe again. To take that even further, used again an idea from Matt's log dedupe concept of the DDT pruning. The dedupe table is split into two chunks, the list of unique blocks that aren't deduped and the list of duplicated blocks. Entries in the unique list have to be there so that when a second copy is written, we find it and promote it, because that's going to know where the existing copy is, which we can't normally find from just a hash. But eventually that table gets really large as you have blocks that haven't deduped. And so we want to find a way to delete some of the entries from there. So if a block's been on there and it hasn't deduped in the last 100,000 transaction groups or whatever criteria we come up with, then we could remove them from this list. It requires some special processing so that when we free the block and we see the dedupe flag, we don't assert that it must be in the dedupe table, but we know that if it's not in any of the dedupe tables and the D bit is set, that it must have been on the unique table and got purged, and so it is safe to free it, even though it's not on the list. We know for a fact that it was only had a single reference. And so looking for ways to basically get rid of the oldest entries because it's the newest ones that are most likely to dedupe. Right? If a block's been on your pool for a year and never deduped, it's probably not going to dedupe tomorrow. But a block you wrote today has a higher chance of deduping tomorrow. But also to deal with the cache performance effects, another feature we have is dedupe preload. So making on demand or automatically at pool import to basically pull the whole DDT into cache so that the performance won't be bad, especially over, say, after a failover to in an HA system. You want that system to pull the DDT in quickly because otherwise in the field, we've seen customers where, yeah, after we reboot or fail over, write performance is terrible for 3 days until the DDT gets faulted in by all the random reads. And so being able to just say, go read that sequentially will improve things. And then to what Matt was talking about, we're looking at, can we optimize the size of those blocks and possibly do some defragmentation of it? Kind of related to the zap shrinking is if entries are too sparse, can we rewrite that section of it to make them less sparse and also mean that a whole subtree of the zap will now be contiguous again instead of being scattered all over the disk, meaning that prefetch will do a better job of getting us more cache hits on dedupe. I mentioned about having 4 sets of 3 slots for every block in the dedupe table. And one of the things we want to do is, part of the reason for that right now is to deal with the different copies equals. But we've got a concept where if we have a copies equals 1 block in the dedupe table, and later somebody bursts a new block with copies equals 2, instead of having to store that in a completely separate slot of 2 DVAs, we upgrade the existing entry by just adding just 1 second DVA to the existing entry. Downside to this is if you write a copies equals 1 version and then a copies equals 2 version, when you're free the copies equals 2 version, we're still going to keep 2 copies in the dedupe table. We won't free the space until the block, that hash goes all the way to 0 references, but I don't see that as being a common case where people are mixing the copies equals property on a lot of stuff.
I mean, I think realistically, you could just say dedupe only works with copies equals 1.
Could do that even,
Like,
I suppose.
I mean, that's what you're saying here totally makes sense, but I think you could probably take it even further.
That would save another couple of bytes in every entry if we just only had to keep 1 DVA for every entry. We'll have to consider that. And then also looking at doing better prefetch. For example, I said the freeze were blocking that system for a long time. Especially with freeze, we know which blocks it is. We have the block pointer, so we can maybe get more prefetching happening there to pull that part of the DDT in so that we're not waiting on a synchronous read later. And trying to look at do we calculate the checksum of the block early enough in the right path to be able to prefetch that part of the DDT and make a performance difference there as well for when we're actually syncing it out, especially if it's an asynchronous write. But the other big thing is, can we fan out the zaps? Right now we have these two giant zaps, but if we did them, say, on a histogram of the record size, we know that, you know, a block that's 4K can't have the same hash as a block that's 1 meg. So can we look in a smaller zap and have more locality, more of all the blocks of the same size will be in the same zap, and maybe improve the performance of reading and writing there. But the biggest part is the log dedupe, a different version than Matt's original one. But the idea is writing an append-only log and maintaining those changes in memory until after some criteria, like, you know, it's been too many transaction groups or the log's too big or too old, to then flush those out to the normal zap data structure. So kind of a hybrid between log space map and Matt's original log dedupe, where we will you know, keep a log so that birthing new blocks is just appending to this log object, but eventually we do flush it back to a normal zap so that we have the option of not having to keep the entire DDT in memory at all times, especially if we're having a dedicated fast device to store the DDT, and we're not going to need to have the whole thing in memory all the time. It gives us back this ability to, you know, fault or to page out the DDT basically, and be able to pull it in off disk again. And yeah, once we reach a certain size or age or whatever, then we would flush these logs so that we don't have to replay them at import, to make sure the time for import or failover doesn't end up getting long. But by grouping a whole bunch of changes to hopefully a smaller zap with the mix of the sharding and this logging, that we'd be able to amortize the cost of all the indirect blocks that we're changing, and possibly be able to make the dedupe leaf sizes much bigger, so that A, they'll have more compression, but also we'll be writing out less fragmented dedupe tables. And then by using separate logs, it means if we, you know, have a log of just 4K writes that are being deduped, we can collapse all of those, write them out to the zap, and then when truncate or remove that log item entirely, instead of having logs that go forever, we'd be able to, you know, pick a certain type of writes, flush them all to the DDT, and truncate the log, instead of having to, you know, have logs where we have to have a ring buffer kind of thing, and we're always scattering around on it. So yeah, the main advantage to this is that we don't end up having to fit the whole DDT in memory, so we don't have to have a limit on the size. So if you have a, you know, a 2 terabyte NVMe to store your DDT table, you can have 2 terabytes of dedupe entries if you think that's a good idea. But it means most of the memory requirement of this is ARC, so it's evictable, whereas the original, Matt's original log dedupe design, that memory was all kind of overhead, and you couldn't ever not have dedupe table in memory. So if your dedupe table wanted to be too big, you just had no choice but to have that much memory. So yeah, that's what we have for design so far. Any questions or thoughts?
So the big problem with dedupe, as I understand it, was tended to be memory usage. Do you have an estimate of how much memory you need to get reasonable performance, sort of compared to your disk space?
Well, it really depends more on your record size, how many different dedupe entries you're going to have for the number of bytes. If all your records are 16 megabytes, it'll be a lot less than if all your records are 8 kilobytes.
Let's assume they're 128K, because that's...
right now, I think they're about 176 bytes of RAM for each entry that it keeps in memory, and something like 200 and something on disk. I forget the exact numbers. But by doing some of the things like what Matt talked about, if we limit it to just 1 DVA in total, then we get a lot different effects as far as how much memory it'll take. We can reduce that by a lot. And so we can get the entries smaller, then it will make a bigger difference about how compactly we can do that. And if we can reduce the amplification cost so that we can allow a larger record size, that will allow the dedupe table to have be compressed again, because right now if you have 4K sectors and 4K blocks, then we just disable compression. And so if we can get that compressed, then we could cache more DDT in the same amount of memory thanks to compressed arc.
So like each of those improvements individually, like they make a lot of sense to me. I wonder if we're really going to do the log stuff, which I think is great.
That's the main thing we're working on.
Is one of the
first.
hugest benefits of this. So like this,
Yep.
like sharded log, which is then backed by, you have like these logs, and then each log has associated with it another
A pair of
disk,
zaps, basically.
another like lookupable on disk structure like the zap.
Yep.
But presumably you are rewriting that zap in its entirety. Like when you flush the log, you're basically going to be like, okay, well, like now we're reading the whole existing zap that corresponds to that log, and then we're writing out all the blocks of it, right?
No. Basically what it would be, the log will be appending the things that we're going to change about the zap. So basically increments and decrements of ref counts. And then when that log gets big enough or old enough, we will apply those changes as one transaction group to the zap.
Yeah.
So we won't have to rewrite the whole zap.
So in order to apply those changes, like if the log has a non-trivial number of entries, then probably every block in the zap will be modified. So in practice, you're reading and writing like every block of the zap, I would imagine. I mean, it depends on all the numbers, right? Like,
Yes.
depends on,
Yeah. If like some of the zaps we've seen, some of the dedupe tables we've seen in the wild are 100 gigabytes.
yeah,
And
you can
if
size,
the log
you're
is
sizing each shard.
Yeah.
You're choosing the size of each shard. So you're choosing the size of each zap, and
well, so the shards have to be static, so it'll be on some factor like the block size. And so the shards won't all be the same size. There's one shard for all blocks up to 4K and another one for all blocks between, like a histogram of the record size.
Okay.
So they won't be equally sized necessarily. It'll depend on how your writes are distributed or your records are distributed.
All right. So in that case, I don't quite understand how you would, like you're saying each shard is arbitrarily large and you're going to rewrite it in one TXG.
Well, we should just be applying the zap changes as if you just made all those changes to the zap in bulk. So the idea is to still keep this quite small, so it wouldn't affect.
So you are you sharding the logs based on the hash? Or
the logs are sharded on the same factor, like the record size or whatever. So that after we write all the changes from a log to the zap, we can truncate that log. Like you atomically replay the whole log. If that makes sense.
It seems like you're just delaying, you're doing the exact same amount of work, but just delaying it. If you're saying like you're logging it, like you're logging it, but then you're doing basically the exact same thing. You're just like spreading it more evenly across the TXGs. Because like when you're playing the log into the zap, those are going to be random accesses.
To some degree, but ideally we but like you said, because we're touching so many of the blocks, we'd amortize the cost of rewriting those blocks and of the indirect blocks, and we would save a lot of IOPS by not having to rewrite so many.
Yeah, if you read the entire log into RAM and then sort it by hash values, then you can apply it in optimal order so that you only have to modify every block of the zap exactly once for an arbitrary number of changes. That seems like that would be good, but in order to do that, you have to be able to limit the size of the zap and of the logs such that the changes can fit in RAM. Which I think that's doable with some tweaks to the design you outlined. But so I think maybe I'd like to understand that a little bit better. Where I was actually going was, if you do that, then then I wonder if the ZAP is really the right data structure for on-disk representation of this. Like because you're talking about making some improvements to the ZAP, which is like, probably non-trivial. And the ZAP is probably not an optimal data structure for this anyways, especially given, like, if you are writing the entire thing at once. Like, let's just say, for example, like if you're writing the whole thing at once, then you can like kind of pre-compute exactly how it should go in order to not waste any space, right? As opposed to like with the kind of existing hash table structure, you're going to have some amount of empty space in every leaf block kind of by design. And it sounds like you're saying that the on-disk structure of the ZAP is what you're going to be caching in memory, and that's what's going to get you the fast lookups, right? So like when you're looking it up in it, you're going to go through the arc, that's going to look in the ZAP, and that's going to give you the value from the lookup. But we don't need to be able to modify that like on the fly. We can just have like some data structure that's on disk. We write it once. Now we might be doing a bunch of lookups in it, and then later on we're going to throw that one away and write out a new one based on the, read the old one, apply the log in memory, and then write it all out again.
Yeah, a bit closer to your original design but sharded.
Yeah, something like that. Or I mean, it doesn't have to necessarily, like, I'm not necessarily.
No, it doesn't have to be an AVL tree or anything specific. Just that concept of, just write the whole thing once, maybe append to it, and then condense and rewrite it.
Yeah, I mean, I think that sharding is going to be necessary to get
small
to
enough
be able
pieces
to process it, to be able to process one whole log in memory at once. And then I think that the other kind of design decision is the on-disk structure also the in-memory structure? Like, that's kind of what you're proposing, is like, it's a ZAP on disk. We're going to have that be the in-memory structure for reading. And then like there's a different structure for the log. And then I guess maybe there's a third data structure that's like an in-memory version of the log that you can do lookups in.
Yeah, right now that's an AVL tree. That's similar to that's how Dedup is normally, and kind of our in-memory structure of what's in the log is a smaller version of that because it has fewer fields and so on. But yeah, it may make sense to consider some other options there as far as making it more optimal in memory.
Yeah, just because like the ZAP is designed to be able to do, lookups and modifications one at a time with, one disk access per thing, per lookup or modification. But you only care about lookups basically, because modifications are going to the log, and then you're going to generate
at least the ability to batch them basically.
Yeah, essentially, like you're going to want to generate a whole new on-disk structure all at once from the contents of the log. So a different data structure might be more compact. This is kind of getting into some of the details, but
it's just, I don't know. We still want the ability to random read into the Dedup table, right?
Yeah, that's the main thing. Assuming that you're using the same data structure on disk and in memory.
We'll
I'm happy
look
to
at that and start applying more of that to our prototype, and we'll have something to show off hopefully for the next call.
Other folks have input on this Dedup stuff, which I think is super cool, even though I do not use Dedup, but I find the design of it is very interesting. All right. Other last topics or mentions for today's meeting? All right, then I'll see you all in 4 weeks. Looks like that'll be July 18th.
Thank you.
All right, see ya.